to my tutorial on calculus 1. We have a question here regarding double integration 0 to 1 from y equals to 0 to y equals to x of y e to power x dy dx. Let's get started. So I'm going to have my solution right here. From 0 to 1, then from y equals to 0 to y equals to x of y e to power x dy dx, right? Yeah, so we will first of all integrate this function with respect to y, then with respect to x, right? Then eventually we are going to substitute the limits of integration and see what the answer will be equal to. So we are going to say integral of y e to power x with respect to y, x will be treated as a constant in that case, or any other function from the y standpoint, it will be a constant. So we are going to say integral from 0 to 1 of the integral of y will be y squared over 2. Then we can just say e to power x remains because from this point it is treated as a constant. So we are integrating from y equals to 0 to y equals to x, then dx, right? So when you substitute the limits of integration, you're going to have x squared over 2 e to power x, and then when you substitute y is equals to 0 here, it will be just a 0, right? So we don't need to put it. Therefore our integral reduces to this with respect to x now, right? So we can now integrate this function with respect to x, and it is a definite integral because we are moving from 0 to 1. And when you integrate this, I'll use integration by parts. I'll first of all pull 1 over 2 outside the integral. So we have x squared e to power x dx, right? So coming here, I can say I have 1 over 2 x squared e to power x dx. Now let u is equals to x squared, so du over dx will be equal to 2x. Then dv is equals to ex dx, so v is none other than just ex. So we are going to say our integral using now the formula. If you have du dx, then v dx, this one becomes u times v minus integral of v du dx, then dx. That is the integration by part, right? So this is what we are going to have now. U is x squared, our v is equals to e to power x. I have not forgotten about the constant there, so don't worry about it, minus 1 over 2 put it in front, so we have a 2. It's not 1 over 2, it's a 2, this one. Then we have x, then e to power x dx, right? This 2 is this one over here. I've decided to pull it on the front because it is a constant, right? Now the other task that I have is to integrate this. I know it can be messy, but let us continue. We have minus 2. Again, we can let this one to be equal to, let's say, you can come here and say, we just create some enough space here. We can talk about let x equals to u, so du dx is 1, v is equals, okay, dv is equals to e to power x dx, therefore v is equals to e to power x, right? So rewriting what we had initially, so we can put all the substances we have. So here we have u, our u was x, our v is e to power x minus, right? So integral again of du dx, which is just a 1, then v, which is e to power x dx, and then we finish. So we have x squared e to power x minus 2x e to power x. The integral of this is just e to power x, so we have e to power x. Yeah. So then we can put our half in front there, then the limits of integration from 0 to 1. All right, we're almost done. I'm going to put it here. So 1 over 2 pulled onto the front. Substituting 1 here, we're going to have 1 squared, that's 1, e to power 1 minus 2 times 1 times e to power 1 plus 2 times e to power 1 minus, we substitute the lower limits, which is 0. So when you put a 0 here, this one will reduce to 0 because we have a parenthesis there, minus 0 because that becomes a 0. Then here we will have plus 2 e to power 0, right? So 1 over 2 into what we have in the parentheses, we have e minus 2 e to power 1 plus 2 e to power 1 minus 2 e to power 0, right? You can finish from here, right? Yeah, so this one is a 0, right? That goes to 0. So we have e minus e to power 0 is just 1, so we have a 2 here, right? So it's like we have it, right? So we can say integral from 0 to 1, that's double integral in fact. So we have y is equals to 0 to y is equals to x of y e to power x dy dx is equals to an awesome answer. I have e minus 2. Thank you.